Hey, my fourth grade mathematicians. Well, I'm so sorry that I'm not here today, but we are going to continue on our fraction journey. I hope you've had a blast in the snow and that you've stayed warm these days that we have been out. But we are going to continue with lesson 4. And lesson 4 is we are going to be working on representing fractions by using various fraction models. So far we have seen fractions modeled on the number line. We have seen fractions modeled on a tape diagram. And today we're going to look at fractions modeled on an area model. That's something that we're really familiar with. So we're just going to make that connection with fractions and area models, okay? So first and foremost, we will do our positive affirmations, okay? So we're going to do our 4 new ones. So everybody take a deep breath in, calm breath out. I will embrace the challenge. I will have a positive attitude. I can grow my brain. And I am capable of learning new things. And the only way to learn mathematics is to do mathematics. Very good. So today I'm working on, we are working on decomposing fractions into a sum of fractions with the same denominator in more than one way. So far we have written equations where we've used those unit fractions. Remember, a unit fraction is 1 out of something, 1 out of a total. So 1/2, 1/3, 1/4, those are all unit fractions. We've even combined unit fractions to find a total of a given fraction. So instead of 1/4 plus 1/4 plus 1/4 equals 3/4, we might write 2/4 plus 1/4 equals 3/4. So we're going to continue using that today and looking at the area model as our guide, okay? So some key questions I want you to think about today is how can we use an area model to represent fractions? And what helps you determine which model to use to represent a fraction? So we may see some situations where a number line might best represent the fraction. We may see where a tape diagram may be the best model to use. So that's what we're going to look at today, okay? All right, so since I'm not there, you know how sometimes we'll jump to the meat. I'm still going to look at some fluency pieces in the launch because there are some fraction pieces I want you to think about, okay? So you do not have to turn to this page now. You can use these pages as practice later, okay? But because I'm not there, we're going to just use this as a review. So you have a sprint with lesson 4, but just take a minute and I want you to look at numbers 1 and 2. And I want you to write the fraction that the shaded amount represents. So whoever may be in here, you might want to pause the video and give them just a minute or two to identify these fractions. Okay, so if you've had your minute or two, let's look at number 1. So what fraction represents number 1? Okay, so you should have said, and I'm going to write the fraction here. I made an oopsie earlier, so ignore my lines. Should have said 1/3. 1 out of 3 parts are shaded. So remember, the top number is called numerator, and the bottom number is called denominator, and our numerator tells us how many pieces are in the whole. I'm sorry, no it doesn't. It tells you how many pieces are shaded or what you're talking about. The denominator tells you how many equal pieces are in the whole. Okay? All right, number 2. What fraction did you write for number 2? Well, even though those shaded parts are not together, you still should have identified as the fraction as 2/4. 2 out of the 4 pieces. Okay. All right, so that sort of warms up our brain about identifying fractions. We're gonna move on into launch, and it's one of my favorites. Which one doesn't belong? So I'm gonna need whoever may be in here to pause the video, give students a couple of minutes to think about which picture do you think does not belong? Okay, so I hope you've had a couple of minutes. All right, so I'm not there to see your answers, so just keep in your mind what you chose as doesn't belong. And remember, sometimes with this routine, I don't like you to talk to each other just yet because I don't want you to change each other's minds. There is not a wrong answer. So someone might have chosen A because A looks like it's representing 1/4, whereas B, C, and D are representing 1/2. Someone could have chose B, that it's more of a linear model. It's not a tape diagram. It's not a circle. It's not a cup. So it's something that is just linear. Someone could have chose C because we've really not looked at a model like that before. We've not looked at fractions with liquids. And someone could have chose D. We've not really seen circle fractions just yet, right? Or fractions modeled with a circle. Someone else could have said B or C because it doesn't show one whole like A and D do. So there's several different things you could defend about which one doesn't belong. Okay, now today what we're gonna do is we are gonna look at an area model. So we've seen, let me move myself down here, tape diagrams, number lines. We've probably seen circular models before, if not in 4th grade, definitely 3rd grade. But we can also use an area model to represent fractions. So if you had a square such as this area right here, how would you use that to model 1/2? So while you're thinking about that, I'm going to draw my model here. So if I had an area model, I would partition or break apart the area into 2 equal pieces. Okay, then I would shade 1/2. And I know I'm not shaded completely, but we know that fractions are perfect. We are not perfect. In fact, I've made lots of mistakes in this video already. But this was how we would use an area model to represent 1/2. Okay, so what I want you to do, I want you to get your journals out, or you can use a blank page, okay? And I want you to draw a square area model, and I want you to represent 6/8. So we see that 6/8 is represented on the number line, that we have 0 to 1. Okay, so the 1 represents 1 whole, and the 1 whole is partitioned or divided into 8 equal parts. And then we see 6 parts shaded. Remember that chocolate bar that we use, that we say, or tape diagram, we like to say chocolate bar. We lay it over the number line and it helps us identify 6/8, or it helps us identify the fraction that we are given. I can see 8 equal parts from 0 to 1 and 6 are shaded. So now I want you to do that on an area model and represent 6/8. So whoever may be in here, you may need to pause the video and give them a couple of minutes to show 6/8. And while you are doing that, I'm going to do it too. All right, so I hope you've had a couple of minutes to represent 6/8 on an area model. And I went and got another color just so you could see, okay? So with my area model, I partitioned the square into 8 equal parts, okay? And I've even written an equation to help me find how to decompose the fraction into unit fractions and represent it using an addition equation. So I wrote 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 equals 6/8. Okay? What other equations could you use or that you could write that would equal 6/8? Yeah, remember, it's been a while, on Friday or Thursday, we took a tape diagram and we folded it and we used 2 different colors to represent 7/8. Remember, and we found different ways that we could write 7/8. So if I chose, let me go back here, and I'm just going to use black on top. So if I chose to represent 2/8 with one color, then I would have 1, 2, 3, 4/8 represented with the blue, and that would still equal 6/8. So take just a minute and see what other equations you could write that would equal 6/8. Okay, so here's just another representation of fractions using a tape diagram. This is 7/12. Okay, you could pretend that this is a sheet cake and you have 12 people at your party and you divide the cake into 12 equal pieces and 7/12 are eaten. Which you know wouldn't be true with me because what fraction would I have eaten? You're right, 1 whole or 12/12. You can also represent fractions on a clock. This time represents 5/6 of an hour. Okay. So any of those models you can use an area model to represent the fraction. So we had 1/2 from the beginning of the lesson, 6/8 that we represented together, 7/12 with the sheet cake you could represent using an area model, and then 5/6 with the clock. You can still represent that using the area model. Okay, so I'm running out of time in this video here, so I'm going to pause here and start a new video, and we are going to do just a couple of more examples together, and then you will be on your way on your problem set. So this video, if you wouldn't mind, whoever may be in here, click the next video, and I'll see you there.